Welcome to STEM Talk.
STEM Talk.
STEM Talk.
STEM Talk.
STEM Talk.
STEM Talk.
Welcome to STEM Talk, where we introduce you to fascinating people who passionately inhabit the scientific and technical frontiers of our society.
Hi, I'm your host, Don Carnegas, and joining me to introduce today's podcast is a man behind the curtain, Dr. Ken Ford, IHMC's founder and Chief Executive Officer Emeritus, who is also the chairman of the Double Secret Selection Committee that selects all of our guests who appear on STEM Talk.
Hi, Don. Great to be here.
Today, neuroscientist and frequent STEM Talk guest Dr. Tommy Wood rejoins us for part 2 of our interview about Tommy's book that is fresh off the press and now available in bookstores and Amazon. And it's titled The Stimulated Mind, Future-Proof Your Brain from Dementia and Stay Sharp at Any Age. So Tommy is an associate professor of pediatrics and neuroscience at the University of Washington, where his lab focuses on brain health across human lifespan. And Tommy is a colleague and a good friend of ours who is also a visiting research scientist here at IHMC.
In part 1 of our interview with Tommy, we discussed his mission to dispel myths regarding the aging brain. Tommy gave us a fascinating history of neuroscience, and he discussed how researchers conduct their study of the brain. Tommy also talked about what is holding us back in terms of addressing the ever-increasing burden of cognitive and mental health disorders that we are experiencing here, not only in the United States, but all around the world.
And today, Tommy also shares science-backed strategies to help people future-proof their brains. We talk about the importance of things like diet and exercise in terms of brain health, as well as the importance of stimulating and challenging our brains throughout our lifespans. So just a little bit of background again on Tommy. He has a bachelor's degree in biochemistry from the University of Cambridge, a medical degree from the University of Oxford, and a PhD in physiology and neuroscience from the University of Oslo.
Before we jump into our conversation with Tommy, we must take care of a little bit of housekeeping. First, a big thank you to everyone who has subscribed to STEM Talk, and extra thanks to all of you who have left those wonderful 5-star reviews. If you're new to the show and you like what you hear, please consider subscribing. And if you enjoyed today's episode, we'd love for you to take a moment to rate the show and maybe even leave us a review. It really helps us reach more people who might enjoy STEM Talk.
Absolutely, and as always, the Double Secret Selection Committee has been hard at work scouring iTunes and other podcast apps for the sharpest, funniest, and most lavishly praise-filled reviews to share on STEM Talk. So if yours makes the cut and you hear it on the show, please send us a note at stemtalk@ihmc.us to claim your very own official STEM Talk t-shirt, proof that the committee does in fact exist.
Today, our winning review, titled Fantastic Podcast, comes from a listener who goes by the moniker RoughDog113. It reads, I absolutely love STEM Talk. Dr. Ford and Don are incredible hosts and ask unbiased questions that really help the listener understand both the science and the storyline of their guests. As a podcaster myself, I try to emulate what they do, as they always create amazing and unique episodes.
Well, thank you so much, RoughDog113, and thanks to all of our other STEM Talk listeners who've helped STEM Talk become such a great success.
Okay, and now on to part 2 of our interview with Dr. Tommy Wood.
STEM Talk.
STEM Talk.
STEM Talk.
STEM Talk. STEM Talk.
Hi, welcome to STEM Talk. I'm your host, Don Carnegas, and joining us today once again is Tommy Wood. Tommy, welcome back to the podcast.
Thanks for having me back.
And also joining us is Ken Ford.
Hello, Don, and hello, Tommy.
So, Tommy, I understand that you were in the UK last week. Is that correct?
Yes, this was the UK leg of my book-related podcast tour. I spent a few days, got to see some friends, got to see some family, but then did some interviews with some newspapers and some of the bigger sort of health-related podcasters over in the UK. So it was a fairly whirlwind and intense trip, but a lot of great stuff, and got to meet and see a lot of fantastic people.
So this sounds like a really exciting trip. That's awesome. And in part 1 of our interview with you, we briefly sketched some of the history of neuroscience and how researchers approach the study of the brain. And Tommy, we really had a good conversation with you about the factors that are contributing to the rise in both cognitive and mental health disorders that we're experiencing, not only here in the US, but also around the world. And a key takeaway from part 1 of our conversation, and also a key takeaway from your book, is that We thought we knew about the adult brain becoming fixed at a certain point and then lack the ability to change as we age, and found out that that's almost certainly wrong. And so the good news is that the adult brain is capable of neuroplasticity, and there's science-backed strategies each of us can embrace to at least partially future-proof our brains from dementia. So part 2 of your book is titled Winning the Brain Game, and that's what we're going to be covering today.
But first, I want to back up for a second and talk about something your father told you while you were in high school. This would be around 2003 or so, and you had just found out that you had qualified to attend Cambridge University. Obviously, you did very well on your exams, but when you told your father the good news, he said, "Now remember, this doesn't mean you actually know anything." You didn't appreciate, I imagine, his snarky comment at the time. But later, as is often the case with things fathers say, you came to realize this was really an important insight that he had shared with you. Could you talk about that a little?
Yeah, you're absolutely right. I believe the first thing he said was congratulations. But then the second thing he said was, remember, this doesn't mean you actually know anything. And when you're 18, obviously you sort of believe that you know everything, and you have absolute mastery of the world around you. And as a very accomplished scientist in his own right, my dad knew that this is obviously not true. And at the time, it's hard to kind of really think about it was hard to think about what he meant by this. But then when you go out and you follow, the future steps of being out in the world and learning how things work, and you realize that what he said is really this fundamental truth about how we should think about the world and also our place in it, as well as the scientific process. And this is, this could be very simple. You think you learn something in high school, and then you go to college and you start to learn more about it, and you realize, oh, I didn't really understand anything about that when I first learned it. But it's also just a really important idea to acknowledge that in reality we know very little. And I think we touched on this in the last episode, that we thought we knew a lot about the brain, and we spent a lot of time accumulating information about it. But in reality, we probably don't know as much as we like to think that we do. And so in the book, I mentioned this story just because I want to acknowledge up front that there's still a lot we don't know. That doesn't mean that we can't, take action right now, but we should always have some kind of humility to understand that there's a lot that we can learn, and that, we will be wrong a lot of the time, and that, that's okay.
I think that's great life advice in general.
Yeah.
So is it fair to say that when you started working with patients, what you learned in textbooks and classrooms didn't necessarily translate into real life medical advice for people? So what you learned, as we touched on earlier, is that there's no one size fits all. And that's true not only in terms of diet, but also in terms of treating patients, and not only those with dementia, but also people suffering from things like chronic pain and other chronic diseases, including obesity. So can you talk a little bit more about this in your experience?
Yeah. I think something that I often say to medical students or prospective medical students is that being a doctor is very unlike medical school, or what you learn in medical school doesn't really tell you very much about the process of being a doctor, or just working with individuals one-on-one. And a lot of my work with individuals is not as a doctor, but as a coach or consultant in some capacity. And when you're in university, you're at medical school or undergraduate or grad school, you obviously learn a lot of very important theory. I think this is a critical underpinning to the work you then do later on. And we definitely don't want to discount that, because that gives you the foundations for you to then apply. But when you think about disease treatment, which is kind of a lot of the focus that I had in medical school, you then go out, and I'm working in elderly care or vascular surgery, or worked in the ER a lot. And a lot of what I saw were diseases that I felt had some element of being preventable, or at least there were things that you could do prior to this person having to engage with the healthcare system. And that's not something that we really learned in medical school. Not that not that doctors don't want to know about that. They would much rather their patients never had to see them, right? We want people to be healthy and never have to engage with the healthcare system. But it was never really set up to think about that or to deploy that kind of information, especially at scale. So I always had this sort of feeling in the back of my mind that there was more that we could do before people engaged with the healthcare system. And so that was one of the things that I sort of noticed, that was different in the real world compared to what I learned at medical school. But then more broadly than that, I think that there's a big difference between theory and practice when it comes to helping people with their health. And you see this a lot. So you mentioned obesity. I find it very interesting that there are, wars are raged around the theoretical underpinnings of what causes obesity, right? There are different models of what might be driving it based on energy intake or carbohydrate and insulin signaling. But the academics who pitch these battles have no experience of actually trying to help somebody lose weight and improve their health. And I think that's very obvious when you hear them talk about it. So the people who are developing advice and frameworks are often very disconnected from the people that their advice impacts. And that's not necessarily their fault because, again, the systems of education and training aren't really set up to allow people to do that. But I think a lot of what I try and do, in my work is acknowledge how difficult it can be to act on advice from sort of formal academic, scientific, medical bodies as an individual. And I think I've just been lucky that my very meandering career has given me access to the kind of experience that would hopefully help people, start to close that gap.
That's well said, Tommy. And there's a paragraph following up on this in the book that I especially liked, and it really reflects something important that not enough people appreciate about science, and it seems especially lately. You wrote, scientists can build evidence and use that evidence to develop a framework to help us understand the world. But at any given moment, we're just one well-designed experiment or one well-phrased question away from having to completely reevaluate the way we see the world. I really agree strongly with that, Tommy, and it's one of the fundamental principles of science. Can you expand on this a little for our listeners from your own perspective?
Yeah, I think this is largely anchored again, going back to my dad's sage advice when I was 18 years old, and sort of builds upon it from there in terms of how we think about the scientific process and the gathering and application of knowledge. And the way that I think about science is it's the process of becoming slightly less wrong over time. And I think that people, who are outside of formal academic spheres are increasingly seeing science being done in real time, right? Because now we have access to papers and podcasts, and you even have things like the COVID-19 pandemic where people were sort of scrambling to figure out stuff, in real time in a way that would decrease mortality risk or decrease hospitalizations. And you feel this frustration within the media or within the population that, well, why can't scientists get this right? Like they said one thing 2 weeks ago and now they've changed their mind. Like how do they, do they even know what they're doing? And that always reminds me of this famous Albert Einstein quote, which is, if we knew what we were doing, it wouldn't be called research. Just kind of underpinning this idea that actually we're just slowly trying to figure things out. And that's really what the scientific process is about. And again, one of the reasons why I wanted to say this in the book is because I wanted to acknowledge up front that I might be wrong about some of the things that I'm saying, right? I would never pretend to have all the answers or try and have this very sort of rigid paternalistic idea of how we should think about ourselves and our brains, because I don't think anybody could ever do that. And so I think it's okay, and we should acknowledge that we might be wrong or that we will be wrong. And this is something that I really try to embody in my own work, particularly when it comes to my work in the lab. So we have a lot of students and a lot of staff who do the day-to-day work of our research. And one of the things that I focus on, probably more than anything else, is when things go wrong or mistakes are made, especially by me, I'm always the first to put my hand up. I'm always to say, that was my bad, my mistake. This is what we'll do better next time. Because I really want students in the lab to know that it's okay to be wrong and it's okay to make mistakes, because that's part of the scientific process. And more broadly, I think this is important because in the book, or even just talking about these ideas here, and we mentioned this a little bit last time, the processes of neuroplasticity, of building and maintaining function in the brain, are largely driven by mistakes and failure. That's what drives the brain to change, is a gap between expectation and reality that requires an improvement in functional structure. And so if you're going to ask people to embrace that, then you have to be willing to embrace it yourself. And I think this is important on a day-to-day basis of how we engage with the world, but also more broadly in a philosophical sense.
Yes, it's a good answer and a great Einstein quote, except he never said that.
Yeah. Well, it's like one of those things where like the quote is, "I never said that," by Einstein, because we like to ascribe things to him that he never said. But
he's the most quoted scientist in history, of course, naturally. But it's phenomenal, all of the quotes that people attribute to him, and then we pick up on it and think it actually was a quote. It happened to me the other day, and somebody shook their head sadly and said, "No, I'm afraid not, Ken." But I have been told it was Einstein. They actually have a website. He's so frequently misquoted. They actually have a website, about whether he actually said these, some specific quote.
That's hilarious. So, Tommy, let's talk about some of the things that people can do to future-proof their brains. And one of the first things that they can do is stop stressing about food. So I really appreciated your message in the Nourish chapter that eating should be an opportunity for nourishment rather than a source of stress. The problem, of course, is that people get so many mixed signals, like red meat's bad for you one day and next day it's okay, same with fat. And one cardiologist will say eat full fat, then another cardiologist will say low fat. People are really confused these days about what to eat. And in the Nourish chapter, you tackle a lot of these question marks that people have about diet. So is it fair to say that a key takeaway of this chapter is that there's no one-size diet that fits all?
Yes, absolutely. I think one of the things that we know, right, I just said that it's dangerous to say that or believe that we truly know something. But one thing that I think that we can say we know about humans is that they are incredibly adaptable and able to thrive in a wide variety of environments. And that's obviously why we populated the entire planet. And this is particularly true when it comes to their diets. And there are people who eat vastly different diets around the world and still, maintain good or excellent long-term health. And I will acknowledge that we don't want to fall into the naturalistic fallacy where we say that, these are the things that humans in the wild, hunter-gatherers groups eat, and therefore that's going to tell us exactly what a perfect human diet should look like. But I think it gives us some signal that we can, as a species, thrive on a wide variety of diets. So one example was a study run by evolutionary biologist Daniel Lieberman, where they looked at 11 different hunter-gatherer groups across South America, Africa, Southeast Asia, and Australia, and looked at what are the foods they're eating, what's the macronutrient balance, where are those coming from? And they found that animal foods ranged from 8 to 88% of calories in the diet. Plants were 3% to 87%. For those who didn't eat just animals and plants, up to 22% of their calories came from honey. So as a result, carbohydrates were 5 to 67% of calories, protein 14 to 48%, fat 10 to 65%. So just hugely varied in terms of the makeup of the diet. And similar findings have been found in other studies, particularly. So these were all groups that lived relatively close to the equator, and other studies have found that, on average, as people move away from the equator, their relative intake of carbohydrates drops and their relative intake of fat increases just based on the foods that are available. And so I kind of take this to mean that if we're trying to look at ways that diets can influence disease risk, and here we're talking about cognitive function and dementia risk, I don't think that whether the food comes from animal or plants or the exact macronutrient balance is the thing that's driving any major, any major issues when it comes to diet and disease. And I think one good example that I have from my own work is a few years ago, working with drivers in Formula One. There was one time when, unbeknownst to one another, two drivers decided to try a specific diet, and they tried the same diet. This is important because these are obviously elite athletes. They have very different structures and training programs from most of us. But in that environment, you remove most of the issues that you have when it comes to trying to make dietary change, right? So these have people who cook all their food, make all the decisions for them. All of this, the food is just placed in front of them, and it's well put together and nutritious and all those kinds of things. And so these were just shifted then to fit a specific dietary pattern. And what we saw as sort of like an overarching coaching group was that one driver, you saw your multi-markers of their health and performance improve. They felt much better. And another one went in the other direction. And that kind of, again, tells me that we have to do a little bit of trial and error in order to try and figure out what works best for us. But as an overarching concept, there's never going to be one single diet that's going to be best for everybody. And I think this has the capacity to be slightly confusing, right? Because then when somebody shows up and says, oh, I ate this way and my health improved, therefore that's how everybody should eat. And that could be the case for ketogenic diets, whole food, plant-based diets, everything in moderation, Mediterranean diets, right? Everybody who says that kind of thing has some evidence to support it from their own experience and maybe some of the experience of other people. But they can't all be wrong or all be right? It has to fit into one framework that allows us to have some flexibility in terms of how these things work. And so hopefully that allows people to step away from some of the sort of the diet wars and focus on some of the things that we know are going to be consistent probably across diets and how they affect health in the brain, and then figure out how to apply that for themselves.
Yeah, that's great, Tommy. And it's clear that what we eat directly affects our cognitive function, well-being, and long-term dementia risk. And when you look at the nutrition research, a common theme that continually shows up is that the first rule of eating for brain health is to maximize nutrients. So can you expand on this detail a little bit?
I call nutrients the great leveler. And this is because we know they're critical. And so here we're talking about micronutrients and vitamins. We know they're critical to health, including several that are linked to an increased or decreased risk of long-term cognitive decline and dementia. And so making sure that we get these nutrients is much more important than where we get these nutrients from. And again, this gives us a lot of flexibility in terms of how we structure our diet. So as long as we know we're getting adequate nutrients, we can maybe be a little more flexible in terms of how that's, where those nutrients come from. So I think about this in terms of an overall framework of how we might develop, a nourishing diet for the brain. So the first, and it has three prongs that sort of overlap. So the first is nutrients. And we know that these key nutrients for brain health and function, and when we're deficient in them or we have insufficient levels of them, we have an increased risk of cognitive decline and dementia. So the first is nutrients. The next is energy. So just ensuring adequate energy intake is critical for the brain, both in terms of avoiding states of low energy availability and states of high energy availability or excess energy availability. Because at either end of that spectrum, we know we see negative effects on brain health and function. And then the final part is pattern, so overall dietary pattern, which is essentially thinking about an approach to diet that allows you to hit the nutrients and get adequate energy for the brain in a way that's sustainable for you based on whatever food you have available, dietary preferences, and other social and societal effects that can have an impact on the way we eat, such as our ancestry, religion, where we live in the world. It's absolutely possible to build a diet that ensures adequate nutrients and ensures adequate energy intake and is sustainable, regardless of where we are in the world. And so that kind of gives us a framework to allow to build towards that.
So as we've been talking about, and as you well know, people are inundated today with so-called health influencers through things like podcasts and social media that promote a revolving host of supposed superfoods and supplements and all the things that we are supposed to be taking on a daily basis. However, rather than stressing about filling your plate with whatever superfood is currently in vogue, you recommend that people tune out the noise and just concentrate on filling their plates with whole, nutrient-dense foods. That seems to make sense, but can you please elaborate a little bit more on this too, Tommy? Thanks.
Yeah. So if we kind of agree that the exact kind of source of our calories and the exact macronutrient balance maybe isn't a primary driver of chronic disease from a food standpoint, I think something that we can say is likely to be driving some of the issues we see with our health based on the food environment is that there has increasingly been a dissociation between calories and nutrients. So food is increasingly energy dense, and we know that once food reaches a certain level of energy density, it's much harder for us to regulate our appetite, largely because sort of our physiology expects this sort of close anchoring between nutrients and calories that no longer exists. So physiologically, it's harder for us to regulate appetite in that setting. And so while food is becoming increasingly energy dense or calorie dense, it's also becoming increasingly nutrient poor. Although fortification of certain foods has helped with that a bit, and that's been an important part of sort of public health. Adding back certain nutrients that were missing from the diet several decades ago. And so what happens is that people tend to overeat and in a state of energy excess, which is essentially what drives metabolic disease, whilst also not getting adequate nutrient intake. So by focusing on whole foods, we decrease energy density because they have more fiber and water and things, which are also critical components of contributing to overall health. And we increase nutrient density. And it's important to say up front that this doesn't have to be exclusive or expensive. So you can take many of the benefits of the modern food environment, like have frozen fruits and vegetables, which you can buy in bulk, and you can be much more accessible and more nutrient dense and more economical. And you can buy things in. We can now buy things in bulk, or they can be preserved in certain ways. We can take advantage of some aspects of that. There are even there are some benefits to food processing, like I mentioned, because they can add back nutrients or they can add back protein that gets lost from the processing. So I don't think that we need to avoid all the trappings of the modern food environment, because actually we can leverage some of their benefits and make things more accessible and affordable. But we do seem to get greater benefits from focusing on whole, minimally processed foods. Again, if we're thinking about beans, legumes, nuts, dairy, eggs, meat, vegetables, fruits, those kinds of things. And one of the reasons for that is because they are less energy dense, more nutrient dense. But also, and this is hard to study right now, but when you eat these foods, you get a whole host of things that we don't necessarily even understand. But we know that you get more benefit from the sort of the whole food matrix that you get certain nutrients from than if you just eat those isolated nutrients. So one example is we know omega-3s are important for brain health, and if needed, people can and should absolutely supplement with them and can benefit from supplementing with them. But there's a stronger relationship between seafood and lower dementia risk than there is between just pure omega-3 status and dementia risk. And that's probably because there's a whole bunch of other things in seafood that we know can be important, like lots of other minerals and compounds, maybe even some that we don't even know what they are yet. This is something that has been called the dark matter of nutrition. We maybe only understand about 10% of what's actually in our food, but there are a whole host of other interesting compounds that may be having an effect. So one that's become more popular recently is ergothioneine, which is mentioned by Bruce Ames when he was talking about longevity vitamins, some of these things that we know are in whole foods that are having an effect on our biology and maybe even contributing to longevity, even though they're not essential. And so ergothioneine is something that you find in mushrooms. So there are these things that we're still learning about that seem to be critical from certain foods that we eat that we just haven't measured or really looked at previously. So we can ensure that we get some of these things while we're still figuring that out, by focusing on some of these less processed foods, especially if we get a diverse range of them.
So continuing on this theme and looking back at your book, you write that when I think about the brain and its many functions, my first thought always goes to the nutrients required to run all the complex, squishy machinery inside the skull. Now, these nutrients are obviously not always easy to get. In the United States and in Europe, somewhere between 15 and 25% of the people have inadequate intakes of most B vitamins and even higher deficits of the minerals iron, magnesium, calcium, and the antioxidant vitamins C and E. Also, nutrient deficiencies differ by sex. Just briefly, women are more likely to get inadequate B12, iron, iodine, calcium, while men are more likely to have too little magnesium, zinc, and some of the other B vitamins. Can you give us an overview of what these nutrients are doing in the brain that makes them so critical to cognitive function?
Those numbers come from this very large analysis that was published in The Lancet, looking at the adequacy of diets in different countries around the world. And I think it's just critical to acknowledge that it's very common for people to have insufficient levels of these nutrients. And then that hopefully gives us a reason to go and seek the foods that are rich in them as much as we can, and then, supplement with them if we need to. But when I think about all these different nutrients, I sort of think about, well, what is it the brain is trying to do at any given moment in time? And there are all these different processes that require these different nutrients in different amounts. So if you're trying to send some kind of signal in the brain, it's, most of them are electrical. So they require the movement of ions, which are minerals that we get in the diet. So things like calcium, very important for mitochondrial signal generation, potassium and sodium. So we know those are important. Then if we're trying to send a signal along axon, the sort of long arms of the neurons that communicate with each other, particularly if that axon goes through the white matter of the brain, the white matter being, where the axons are sheathed in fat, in myelin, and that helps the signal be sent much more quickly. One nutrient that's really critical to white matter development and function is iron. And we see that in the developing brain. We also see it later in life where individuals who have inadequate iron status or inadequate iron intake tend to lose structure and function of the white matter more quickly. And we know that white matter structure and function is one of the best predictors of long-term cognitive function. So iron is really critical. And then your signal gets to a synapse where your neurons talk to each other. And one thing that is highly concentrated in synapses is the fat, omega-3, a long-chain omega-3 fat, DHA, which tends to come from seafood. And if you want DHA to be in a membrane of a cell, then it needs to be attached to a head group as part of a phospholipid. So those head groups are often either derived from or related to compounds like choline that you can get from things like eggs and liver, but also related compounds like serine, so phosphatidylserine, which is based on an amino acid, or phosphatidylethanolamine, which is another sort of structural compound that you can, again, get from some same foods as choline, but also you get in things like whole grains. And then if you want to attach that DHA to that head group, you need the processes of methylation. And methylation also helps you interconvert things like choline and ethanolamine. So then you need a number of B vitamins that help to run that process. So B12, folate, B6, riboflavin. And that kind of helps you then build the structure of the synapse so that it can function. You then want to make some neurotransmitters to kind of send that signal. And these require, depending on the neurotransmitter, they require a whole bunch of different nutrients. But one example is serotonin. And to switch on the gene to make serotonin from tryptophan, you need vitamin D. So vitamin D is critical for serotonin production. And then when you release a neurotransmitter, it's often released with some other kind of neuromodulator that affects how it binds to the synapse on the other side and activates the next neuron. So zinc and magnesium are very commonly released as neuromodulators. And then the signal can continue. But then this whole process is very energy intensive, and running this system could generate a lot of oxidative stress. So then we know that that's where vitamins C and E become critical. And then there are also a whole range of antioxidant compounds that are found in foods that tend to be associated with lower risk of cognitive decline and dementia. And there are also studies that look at these compounds in the brains of individuals who did and didn't have dementia. And those who had dementia tend to have lower levels of these compounds. So things like the anthocyanins from berries that make them sort of purple and red. There are similar compounds in coffee and tea, and also in the roasted skins of nuts and seeds. And then some of the other colorful compounds like lutein, zeaxanthin, astaxanthin. So that's red and yellow vegetables. And astaxanthin is found in, it's what makes salmon and prawns pink. And so these tend to have these sort of antioxidant properties that can also help things like vascular function, that improves overall brain function. So all of those different nutrients then are required for different stages of that process. And I think, again, it's useful to kind of know where they're acting, but also to know that you can find lots of these foods together and very regularly if you eat, kind of how I was mentioning earlier, rather than having to worry about, supplementing each of those individually, but which quickly can become quite overwhelming.
Well, you mentioned supplements again, so this is a good time, I think, to discuss it. It's, in some circles, a controversial topic, I think largely because there's a lot of sort of snake oily influences out there who are promoting special concoctions and special magical supplements. My favorite are those Hawking quantum supplements. And, my alarm bells always go off when somebody does that. So following up on this, you have an excellent section in the book titled, appropriately enough, To Supplement or Not to Supplement. You could have had it continue, that is the question, right? You point out that there is evidence that targeted supplementation can fill these nutrient gaps that we might have in our diets and thereby improve cognitive function. And you touched on this just a minute ago, but I'm wondering if you could discuss a framework for how people could think about adding or not adding via supplementation key nutrients to their diet.
You're right that supplements quickly become very controversial, and rightly so. Right now, like wherever you look, it seems that there are these supplements that are mentioned frequently on podcasts, and when you go and look at what's in them, it's a whole bunch of proprietary blends, and you actually have no idea what you're taking. And honestly, I'm amazed that these things are still allowed nowadays. The fact is, though, that if you need to supplement, there is some evidence that you can get benefit from it. So that largely pertains to some of the nutrients that I mentioned previously. One of the easiest ways to determine this, or whether this might be needed, is to measure levels of markers of some of these nutrients. So very simple things that have a big impact, and we know can have a big impact if we then supplement in order to change them, include omega-3 status, vitamin D, iron again, and then the B vitamins associated with methylation. And the marker that tends to be measured for this is homocysteine. So homocysteine goes up if we have insufficient levels of one or more of those B vitamins that I mentioned. And when you look at randomized controlled trials, we see that those who are insufficient in these vitamins and then supplement accordingly then see either slowed brain atrophy, slowed cognitive decline, and potentially decreased risk of dementia across all of those different nutrients. And so for omega-3s, like that includes mood as well as cognitive decline, vitamin D the same. Some of the best evidence looks at omega-3s and B vitamins for homocysteine. And the first trial of this was done in Oxford. It's called the VitaCog study. It was run by Professor David Smith, who's was former department chair of pharmacology at Oxford. And what they did is they looked at individuals who had elevated levels of homocysteine, and those that they thought were highest risk were those with a homocysteine above 13, although they also saw benefit in those who had a homocysteine above 11. And they supplemented with B vitamins, and their supplement was folate, B12, and B6. And when they saw significant reductions in homocysteine, that was due to the B vitamins, that was associated with a slowed rate of brain atrophy and slowed rate of cognitive decline. But interestingly, and this really goes to what I was mentioning earlier about trying to get, when you're talking about DHA and a synapse and its function in the brain, what they found was that the benefit from B vitamins was much greater in individuals who had good omega-3 status. And this has now been repeated in multiple randomized controlled trials. So the B-Proof study found something similar. And then the Omega-AD trial came from the other side. So they supplemented with omega-3s, but found that the benefit was only seen in those who had normal levels of homocysteine. And I think that makes sense when you think about how these nutrients interact to have their effect in the brain. So this is important for a number of reasons. One, it shows that especially if we know that people are insufficient in these nutrients and we supplement to improve their levels, that significantly changes cognitive function and brain structure and function. But it also helps us to understand that just thinking about nutrients one at a time and supplementing with things one at a time doesn't really make sense, because we don't know what one individual might need. And there are several studies where they looked at homocysteine historically and they gave B vitamins, or they looked at omega-3s and they gave omega-3s and then were surprised that just giving omega-3s wasn't enough to decrease the risk of dementia. And this is because we're again sort of approaching it in this very reductionist way that, we'll give this one thing and that's going to be the solution to everything, without measuring whether somebody needed more omega-3s or not to begin with. So this makes it more complicated, but also means that for some of these critical nutrients that we know have this direct connection to dementia risk, these are things that we can easily measure, right? People can get this from their physician. They can get access to these tests if they need to, or we could just make sure that we eat seafood or take omega-3s regularly, and then get enough B vitamins by, again, sort of eating a nutrient-rich, whole foods-based diet. So you don't need to test, but that's where some of the best evidence exists, that if we then want to intervene with a supplement.
Absolutely. That makes a lot of sense. And I'm an avid tester myself, as you're probably not surprised to know. Let's talk about another topic that in some circles is controversial, though in my view should not be, and that is red meat. There are some dietary protocols that promote limiting or actually eliminating red meat altogether. And can you weigh in how, in your view, people should think about red meat and its consumption?
Yeah, I think you and I are almost certainly on the same page, which is that red meat can be a very important source of protein and nutrients in the diet, and in the right context actually has very little risk, if any, with any of the sort of chronic diseases that are often associated with it. When you look at most of the data that kind of says red meat is associated with some kind of chronic disease, and including dementia risk, often this is based on very poor quality dietary data. It was largely driven by healthy user bias. But when you look at randomized controlled trials where they add meat to the diet, and there was one that was actually very recently published where they had people do a crossover trial. They put them on a plant-forward diet, so very similar to how we've kind of talked about diet already. So minimally processed, nutrient-dense diet. Then they added red meat to the diet. This was in the form of pork, and saw essentially no negative effects on any of the biomarkers of health. And when you look at the context of red meat intake associated with any kind of chronic disease, it's usually in the context of a low quality overall diet. And there are some studies that suggest that a lot of that signal is driven by just differences in the population. So there was a classic study using AARP data that looked at red meat and multiple causes of death, and found that even after sort of adjusting for confounders, those who ate more red meat were more likely to die of accidents. And obviously red meat isn't driving that, but it just tells you that there's fundamentally there's differences in the population that are driving some of these differences that haven't been accounted for in some of these large epidemiological studies. But again, in randomized controlled trials, if you add red meat to the diet, there's no change in blood sugar, no change in inflammation status, a very minimal change in some of the, say, lipids associated with cardiovascular disease risk. Then other studies suggest that those who eat some minimally processed red meat have a lower risk of dementia, have a lower risk of mental health disorders, particularly depression and anxiety. And I think this is probably because of the B12, the zinc, the iron, and these things that are in red meat that we know are important for brain function. So in the setting of a really high quality diet, I think that red meat can be an important part of that, but doesn't have to be, right? As long as we're still hitting all the necessary nutrients from whatever we are eating. And so one nice example of this, again, this is now using observational data again, but there was a study using data from the UK Biobank where they sort of look at how people are eating. They score their diet on a Mediterranean diet kind of scale. And one of the diets that's been sort of most promoted for brain health is the MIND diet, which was a kind of a mashup of the Mediterranean diet and the DASH diet. And one of the things that they include is minimizing red meat intake. When they looked at how Mediterranean does your diet look, those who ate something that looks closer to it or report eating something closer to a Mediterranean diet, they had a lower dementia risk. But when they isolated all the individual foods in that scoring system, there was no one food that said this is the food that's driving that signal of the diet. And that included red meat. So if you take the decreased red meat out of the score, you still see a lower dementia risk. So this then brings me back to this idea of overall dietary pattern. It's not that any one of these foods needs to be lionized or demonized. It's this overall overarching idea that you have higher diet quality, you have lower calorie density, higher nutrient density. And that's achievable with the Mediterranean diet, which has kind of been, it's been manufactured. The Mediterranean diet isn't one thing. But it's also possible in any kind of scenario, and then including red meat as part of that can be important because of it. It can be a great source of protein and nutrients.
Yes, there's really nothing more annoying in some regard. Well, there are a few things more annoying, but little more annoying than people constantly promoting this nebulous thing, the Mediterranean diet. I've been all over the Mediterranean, lived all over the Mediterranean, and it's not a very homogeneous diet.
Absolutely not.
Olive oil is pretty much everywhere. Garlic is everywhere. But, some of these folks eat prodigious amounts of lamb, for example. Others, huge amounts of pasta. They're very, very different diets. And so when someone says, consume a Mediterranean diet, I'm not quite sure what that means unless it's very carefully specified, and then probably shouldn't be called Mediterranean. It should be some specific diet that was studied.
So speaking of Mediterranean diet, seafood has recently been getting a bad rap as well because of microplastics, mercury, and other contaminants in our oceans. However, studies show that the consumption of fish is associated with better cognitive function and also reduced dementia risk. So, Tommy, what are the pros or even cons when it comes to eating fish?
Something that we see with seafood, but also with food more broadly, is that we often tend to focus on the negatives without appreciating that most of the positives outweigh any negatives that come along for the ride. So we see something very similar with conventional versus organic vegetables and fruit, or grass-fed versus conventionally raised meat. In reality, the benefits of just eating those whole nutrient-dense foods vastly outweighs anything that might come for the ride. So maybe some pesticides, or which we can't completely minimize that. But in general, all the studies suggest that the benefit of eating those foods dramatically outweighs any of the potential downsides. And this is important, again, because otherwise we construct these barriers to entry. You shouldn't eat fruits and vegetables unless they're organic. Well, then what are you going to eat instead? Or you shouldn't eat red meat unless it's grass-fed. Well, what if I can't afford grass-fed red meat? Does that mean I shouldn't eat meat? And in reality, I would say it's much more important that you eat foods of that type and worry less about some of these downsides. Though, we can certainly consider, the importance of how food is raised on, the environment and the soil quality and all that kind of stuff. You don't want to minimize that. But when you're trying to create a framework that people can actually deploy based on their access and resources, we need to make this as accessible and doable as possible. And so then this, I think, brings us back to seafood. And one of the most interesting studies in this arena looked at the mercury in brains of individuals and found that those who had dementia or who had experienced some cognitive decline had lower levels of mercury than those who had maintained cognitive function. And now we know mercury is a heavy metal. We know it's neurotoxic. But the reason for this was that mercury that was in individuals' brains was coming from seafood. And the net benefit was that even though you're consuming some mercury because it's in your seafood, there still seemed to be a net benefit in terms of maintaining cognitive function because of omega-3s. There's selenium in seafood that offsets some of the negative effects of mercury. And there are also several studies looking at neurodevelopment in kids who eat a lot of seafood or not. And again, you see something similar. Like there's a net benefit of seafood, even if that means potentially consuming some mercury. So across all of these ideas, I think we have to appreciate that eating these very nutrient-dense foods, there are going to be some things that come along for the ride. Like if you eat vegetables, there's going to be some heavy metals in them. And like everything that we eat, breathe, and consume, unfortunately, has something that we could focus on and say, well, you can't do that because it's got this in it. but all the evidence suggests that the benefits outweigh the downsides. So yes, it's true that microplastics are probably accumulating in fish, as are heavy metals, and it's not that we should ignore that. We should still try and eat maybe smaller fish, sardines, mackerel. They're less likely to be contaminated, and they're incredibly nutrient dense. But I think we do ourselves a bit of a disservice if we always focus on the negative impact of other things that might be coming along for the ride in foods, when actually, the majority of the evidence suggests that eating that food, the benefits outweigh, any potential downsides.
That's a great answer, Tommy. So for people who are thinking about buying Tommy's book, I want to point out that he has an excellent section that lists specific foods that are high in certain nutrients, like foods that are high in iron and omega-3 fatty acids and B vitamins, etc.
Well, Tommy, we often hear from our listeners about the genetic basis for dementia, in particular Alzheimer's, and it worries a lot of them. Recently, there was a paper, in fact, last year, we discussed it at some length between us, showing that ApoE4 carriers that are homozygous, in other words, they received this from both parents, essentially they showed an absolute deterministic characteristic, meaning that if you were an ApoE44, you would develop dementia. And it was a very strong claim in the paper, and it seemed erroneous to me and certainly excessive. But I wondered if you had thoughts about that, further thoughts about it. I remember we discussed it, I think it was in the fall of last year.
Yeah, I was really honestly quite dismayed by that paper because of the amount of fear that it generated, and unnecessarily so. What they did was they compared timing and onset of dementia symptoms on average in individuals who have early onset Alzheimer's disease, so driven by mutations in the amyloid precursor protein or one of the presenilin genes. And they also included Down syndrome as a potential cause of dementia. And they supposedly showed that the onset and timing of dementia in individuals who are ApoE4 homozygotes sort of closely mirrored these other drivers of dementia. Even though when you actually looked at their plots and their data, that those factors didn't align. They just seemed to want to say it, so they said it. Because if you looked in the supplementary data, there was a whole bunch of stuff around accumulation of neuropathology. And yes, it's right that those who are ApoE4 homozygotes do tend to accumulate neuropathology much faster. But we know that there's not a perfect, by neuropathology I mean amyloid and tau. But we know there's an imperfect connection between amyloid and tau burden and cognitive decline and dementia. We talked about that a lot on the previous episode. And when you look at how risk factors for dementia translate to dementia risk based on ApoE genotype, what you see, interestingly, is that ApoE4 is really just a risk multiplier rather than an absolute risk factor. And there are multiple populations around the world where having one or more copies of ApoE4 doesn't translate to increased dementia risk. There are also studies that show that you may benefit more from certain lifestyle interventions if you have a one or two copies of ApoE4, because it's then offsetting some of the additional risk. So omega-3 fatty acids are potentially more important, or you get more benefit if you're an ApoE4 heterozygote or homozygote. Physical activity results in a greater reduction in risk in those who have ApoE4. We see that some anti-inflammatory interventions may have a bigger effect in those who have ApoE4, because one of the things that ApoE4 does is it increases neuroinflammation in the brain in response to insults or exposures. So that's true for both statins, but also anti-inflammatory drugs like NSAIDs. So I think everything that it tells us, what we know so far, is that the effect of ApoE4 on dementia risk is really a gene times environment interaction. And so it's amplifying other risk factors that we have in our environment. But by the same token, that means that if we mitigate or minimize those environmental risk factors, they will get a greater benefit or greater risk reduction as a result, which could then ideally mitigate the majority of the increased risk. So when I believe well-meaning scientists publish papers saying, oh, there's so much additional risk here. It looks like early onset Alzheimer's disease. It's incredibly disempowering for the individuals who actually, have that genotype. And, this is kind of what I was saying earlier when it comes to, obesity or other behavior change stuff, where the people publishing the papers are so disconnected from the individuals who those papers will impact that they don't realize, what they might do when people then have to see this information and interpret it and figure out how to act on it for themselves. So everything I think we know about ApoE4 and other genetic risk factors for dementia, including like polygenic risk, you can still see dramatic decreases in risk by addressing common lifestyle risk factors, which then automatically means that it's not the same as some of those other conditions that they were trying to compare ApoE4 homozygotes to.
Yes, the paper actually contradicted itself in a few places, as we discussed in the fall, and it presented ApoE44 as an absolute determinant, not as a risk factor, but as the thing itself. And that, as you said, is incredibly demotivating and depressing to people carrying that genotype. The people that reached out to me, at least, tend to be the people that listen to the podcast and are very health oriented.
Yeah.
And it was like, what? I may as well give up. It was really a very tough thing, I think, for a lot of these folks to read.
Yeah.
STEM Talk is an educational service of the Florida Institute for Human and Machine Cognition, a not-for-profit research organization investigating a broad range of topics aimed at understanding and extending human cognition, locomotion, health span, resilience, and performance.
Well, Tommy, let's switch gears for a moment and talk about energy and the brain. And this is one of my favorite topics. As everyone knows, I think, the brain uses roughly 20% of our energy, but comprises only 2 or so % of our body weight. Perhaps unsurprisingly, a primary driver of brain structure and function seems to be energy availability. We discussed this topic in episode 59 with Stephen Cunnane at some length. Can you touch on the importance of getting enough energy for our brains and what the implications are of enough and not having enough?
There's a really nice paper that was published by Kaplan et al. In PNAS in 2023 that I think shows this idea really nicely. And what they did was they looked at energy availability and they measured cholesterol levels and body composition as kind of proxies of energy availability across multiple populations. So at one end, they had the Bolivian Chimane, who we talked about on the previous episode. Then at the other end, they had US and European populations. And in between, they had the Mosetan, who are sort of another group of Amerindians who are sort of kind of in between the Chimane and the more industrialized societies in terms of their level of industrialization. And so they had this kind of broad range of energy availability across these groups. And they looked at brain volume as a marker of brain reserve, which we know is really critical for long-term dementia risk. And what they found was that at the low end, so when energy is scarce, the brain volumes are smaller. And this is makes sense, right? If you don't have additional energy, you only invest as much energy as you need to kind of run the brain on a day-to-day basis. You're not sort of thinking about building bigger reserves, or you don't have the capacity to build bigger reserves. So we see something similar in terms of the trajectory of brain volumes in the US over the past 100 years or so. And this was something that, again, that we mentioned in the previous episode, where age-specific incidence of dementia has decreased over the past several decades. And in a study from the Framingham cohort, they found that over time, particularly sort of in the middle of the 20th century, brain volumes started to increase, and that was associated with a decreased risk of dementia. And I think a lot of that is probably driven by increases in energy availability from the diet as we left, kind of came out of the Second World War and the Great Depression. More energy becomes available as, our food environment changes. And, at least early on, that was invested in by our bodies in bigger brain volumes that then translated to lower dementia risk. We know that the brain is very energy hungry, and that this can influence brain structure even in very short time periods. So there was this fascinating paper that was just recently published in Nature Metabolism, where they took individuals and scanned their brains before and after a marathon, and found that even within a few hours of continuous running, the myelin of the brain shrank slightly, with the interpretation being that because running a marathon puts you in a very significant energy deficit, in order to maintain its function, the brain was eating up fat from its own myelin in order to maintain energy status. Longer term, their brains recovered, and it wasn't necessarily a bad thing. But it shows that the brain is willing to sacrifice its volume in order to maintain function in the setting of low energy availability. And chronically, this I think translates to larger long-term risk of decline and dementia, because you just don't have that reserve that we know is critical for maintaining function. And we see this, I've seen this very frequently in athletes, and it's also you see it a lot in the scientific literature, where it's very common for athletes to experience what we call low energy availability. So they're just not consuming enough calories in order to recover from or fuel all the exercise they're doing. And as a result, cognitive changes are very, very common. So mood issues, sleep issues with focus and attention. And I think a lot of this is just driven by the fact that you don't have enough energy to run the brain fully. So this kind of tells us that, when I think about the overall pattern of, or the overall framework for diet and brain function, enough energy is really critical, because we know that there are these very common low energy states that can negatively impact brain structure and function.
So, Tommy, as you well know, fasting and time-restricted eating have been becoming increasingly popular in recent years. We discussed time-restricted eating in depth in episode 7 and also episode 133 with Mark Madsen. So we're curious, in your view, what are some of the key considerations when thinking about fasting and time-restricted eating?
They can be fantastic tools if they help people to manage energy intake, which is obviously where they've primarily been deployed. So if you're experiencing excess energy availability, which is, like I said earlier, the primary driver of metabolic disease, metabolic syndrome, right? High blood sugar, high triglycerides, high blood pressure, elevated waist circumference, which we know is a significant risk factor for dementia. If you can use these tools, intermittent fasting or time-restricted eating, to help manage your energy intake so you can, help treat or prevent energy excess, which we know is problematic as well, then I think they can be great. However, when you look at the literature, this sort of intermittent fasting and time-restricted eating have been sold as like some kind of metabolic magic, which they really aren't. And even, papers by, luminaries in the field sort of overemphasize mouse data to say that intermittent fasting or time-restricted eating, has some kind of additional effect on health and metabolism beyond just the effects of reducing calorie intake, when in reality, that doesn't seem to be the case in humans. Really, when we compare these different dietary structures, the best outcome is often driven by which results in a more sustainable reduction in calorie intake. So for some people, that might be intermittent fasting. For some people, that might be time-restricted eating. But I think there is also a risk that when we try and layer these different eating strategies on top of, less energy-dense diets, especially when we're told that calorie restriction is going to be some sort of boon to long-term health and longevity, I think people risk ending up in that low energy availability state. And so, yes, they can be important therapeutically, or if people, have evidence of metabolic disease, as can many different dietary approaches. But often when people are very health conscious, I think they err too far on that side where they may end up in a low energy availability state. And this may be a long-term risk in terms of decreasing brain reserve. So when I think about these different dietary approaches, I think my favorite quote comes from Charles Brenner, who says that caloric restriction, which is essentially one version of these things, right? Time-restricted eating and intermittent fasting, they work if they do through caloric restriction. Caloric restriction extends animal lifespan when compared to constant access to food. However, it is more accurate to say that unrestricted access to food is a life-shortening condition that is unlike conditions in the wild to which animals are adapted. So all of these different things are just tools to try and overcome the modern food environment. They're not sort of magic in their own sense. So if these different strategies help you to maintain an overall healthy dietary pattern, that's great. But beyond that, I do worry about some of the risks if we become overly restrictive.
Thank you for that thoughtful response. Really, in my view, and I think yours as well, the far larger issue, pun intended, in the U.S. and other industrialized nations is the modern food environment makes it far too easy for us to have access to more food and more energy than we need. And this has led to an epidemic of obesity and type 2 diabetes, which are associated with, as you mentioned earlier, smaller brain volumes, accelerated cognitive decline, and higher risks of dementia. Can you talk about how excess energy availability is contributing to a projected increase in overall dementia burden in the oncoming decades?
Yeah, I focus on this idea of excess energy availability because it again kind of speaks to this idea that there's a spectrum. There's a sort of bell-shaped curve when it comes to energy availability and brain volume and brain reserve. And you're right, at the upper end, that's where we're probably seeing a much larger risk at the population level. I think in those who are very health conscious, I do sometimes worry about the lower end, but the upper end is what's really affecting us at the population level. And dementia risk is projected to potentially double or triple in the next 2 or 3 decades. And I think that's largely driven by some of these changes in metabolic health at the population level. And so if we go back to that Framingham study, as they were looking at individuals sort of later into the towards the end of the 20th century and into the beginning of the 21st century, though many dementia risk factors were decreasing, obesity and type 2 diabetes were continuing to increase. And so I think, we're still on this upward trajectory of metabolic disease that we know is a significant risk factor for dementia, high blood pressure and high blood sugar being 2 of the most consistent risk factors for dementia at the population level. And so one of the reasons why dementia risk is projected to increase over the coming years is because of this, increasing burden of metabolic disease at the population level, which directly impacts brain structure and function, but through vascular disease as well as inflammation, oxidative stress, sort of all the different things that we know can impact brain function. So the only, I guess, kind of potential caveat to that right now is that we are seeing a big shift in terms of therapies that we know can have a big impact on metabolic disease. So the GLP-1 receptor agonists, and then the multi-incretin receptor agonists, now sort of tirzepatide and retatrutide, they do have quite an impressive impact on heart disease risk, blood sugar, blood pressure in individuals who are experiencing excess energy availability. So it's very possible that those medications are changing the tide of that at the population level. And we may be, even though we're not addressing it through lifestyle, we may be addressing some of that long-term dementia burden through these medications. We then have to be careful to think about, if you're dramatically decreasing food intake, which is largely what these drugs do, we still then need to be making sure we're getting enough protein, we're getting enough nutrients to kind of maintain muscle mass and brain health and all those other things. So they're not going to be this panacea, but there is some evidence that maybe we're changing that trajectory because of these new medications, which has pros and cons. But certainly, if we're thinking about dementia burden, that may be potentially helpful.
Also, if you think of the population dementia burden, we have an increasingly elderly population, which has to be a primary driver.
Yeah. So one of the we talked about last time, age-specific incidence of dementia. So you're less likely to be diagnosed with dementia at 70 now than you were 20 years ago. But because we're living longer, you are still more likely to ever get dementia because you will live longer and not die of something else first and then end up with dementia. So both of those things are happening at the same time.
So Tommy, how do people in a practical way assess whether they're feeling the needs for their bodies and brains? Do you have any recommendations in that space?
The best evidence really kind of fits into those two things that we were talking about. So ideally, if you avoid any of the criteria for metabolic syndrome, so high blood sugar, high blood pressure, low HDL cholesterol, high triglycerides, and high or increased waist circumference, if you don't have any of the criteria for metabolic syndrome, then you're probably that's going to be the vast majority in terms of worrying about risk of excess energy availability at the high end. And so this is, again, stuff that people can easily test, can measure, get through their doctor, is the kind of things that, doctors are focused on for important reasons. And then at the low end, people might think, particularly if they've had significant changes in their body composition, they've lost a lot of weight, they're losing cognitive performance, physical performance, issues with sleep, issues with mood. Changes to gut function are also very common in low energy availability states. If women are still cycling, changes to the menstrual cycle. You can measure some of this stuff again on blood tests, so changes in sex hormones, thyroid hormone. If any of those are happening in the setting of a significant restriction of calorie intake, then I would worry about function at the low end. So a lot of this can be driven by essentially how we feel day to day, as well as our changes in performance and well-being. But some of it can be addressed just with some very simple tests that doctors will do to kind of track some of these aspects of metabolic health.
Another key component of brain health is the extent and methods we use to stimulate our brains, especially as we age. This is something that Dr. Rudy Tanzi echoed when we interviewed him on episode 174. Rudy said, learning new things as we age is the best way to protect our cognitive abilities. Since your book is titled The Stimulated Mind, I think it's certainly fair to say that you would agree. Can you talk about the importance of stimulating and challenging our brains throughout our lifespan, and particularly as we enter the older years?
Absolutely. And you're completely right. I very much agree with Rudy on this point, and that was an excellent episode of the show. And he talks about how learning really drives the production of new synapses, which create this idea of a part of what we mean in terms of brain reserve and cognitive reserve is having additional capacity in the system, because we have better connected networks and structures in the brain that are driven by these neuroplastic processes that are in kind driven by learning. And when we look at what it takes to build cognitive function and maintain cognitive function, the strongest signals seem to come from the stimuli that our brain receive. So cognitive function on average peaks at about the time we leave formal education, and the higher our level of educational attainment, the higher and later the peak. So the more time we invest in essentially learning, where we're professional learners when we're in school, that seems to build sort of the capacity in the system. But we also know that the trajectory of downward change as we get older in cognitive function is then driven by how we continue to use our brains later in life. So there are studies from individuals looking at how complex their jobs are, or how cognitively stimulating or challenging their jobs are. And those who have more cognitively stimulating or more complex and less repetitive jobs, they have a slower rate of cognitive decline over time and a lower risk of dementia. We also know that if we start to give individuals who are older new cognitive tasks or challenges in sort of randomized controlled trials, and these could be related to learning music, learning languages, learning open skill or complex sports, dancing, we then see improvements in brain structure and brain function, again, through this process of challenging our brains. So pretty much anywhere you are in the trajectory of the lifespan, the amount and complexity of cognitive stimulus that you apply to your brain seems to be a primary determinant of how that brain then functions, which would then translate into changes in cognitive function and ideally, hopefully preventing cognitive decline then as we get older.
So, Tommy, the process of a brain adapting to a stimulus is very similar to how muscles respond to resistance exercise. So this realization came to you after you met Josh Turknett, who's a neuroscientist who loves the banjo as much as you love weight training. Can you talk about how you realized that your and Josh's respective hobbies had more in common than you originally thought?
Yeah. I think I write in the book that Josh loves the banjo as much as I love bicep curls, and this was really where our worlds kind of came together. As I was sort of started talking about a minute ago, when you look across almost any tissue in the body or any organ in the body, its function is directly driven by the demands placed upon it. And so that's true when we think about our muscles in terms of strength and muscle mass, right? If you want to get bigger and stronger, then you need to apply mechanical tension to your muscles to stimulate the muscles to grow and adapt and improve their function. It's true when we think about the immune system and when we're exposed to infections or vaccines, right? That's how we boost function by stimulating the immune system. It's true even when you think about things that you might expose your liver to. So your liver gets better at metabolizing alcohol if you consume more alcohol. That doesn't mean that you should consume alcohol to make your liver function better, but it just means that these stimuli that we apply to our body is a primary driver of how they then function. And this is, when you look at the underlying biochemical processes, increasing demand at the cellular level and how it affects the processes of maintenance, repair, reversing or preventing some of like the hallmarks of aging. What you see in skeletal muscle when you do bicep curls in the gym and what you see in cells like neurons and networks in the brain when you stimulate them with very complex activities like playing the banjo, you see very similar adaptation mechanisms. And so there are these core processes that drive the function of tissues when we apply some kind of demand to them. So that was really working with Josh and speaking to him about some of these ideas were really kind of like the genesis of some of these concepts of how we might think about the brain like a muscle. And that's useful for me as somebody who enjoys lifting weights, but also because I think it's something that conceptually people can understand, right? We know that if we want to get fitter or stronger, we have to do some kind of exercise. And the brain really seems to be the same.
Tommy, I'm wondering if, as with exercise, and particularly resistance training, there's sort of a muscle memory component. And people who have earlier been very strong or very fit or both seem to have an advantage when they re-engage in training. I wonder if that's also the case with the brain, or are we carrying this analogy way too far?
No, I think there is some similarity there. And this also relates to that idea of reserve that you build when you build these synapses. And we know that as the brain starts to lose volume as we get older, and the loss of volume is one of the processes that happens as you sort of experience this trajectory of cognitive decline and potentially future dementia risk. But most of the initial volume loss is not the loss of cells. We used to think that these neurons are dying and they don't recover because we don't the adult brain doesn't undergo neurogenesis like we talked about previously. But that's not actually true. What's happening is that the cells are just shrinking down a bit, and this is very similar to when you've previously trained. You built a lot of muscle mass and strength through resistance training, and you stop. You have this muscle memory, and it's largely due to the development of satellite cells, part of sort of muscle stem cells, and like you have this memory of the previous function that you had, even though volume is lost. And so then when you train again, a lot of that you're regaining that is because you're just replenishing that volume and re-stimulating those tissues that had that previous function. And so the brain, I think, is the same. So we early on, even if we're losing some capacity, that capacity is still there's potential for that capacity in that tissue because those cells are still there. They just need to be re-stimulated, and you just need to apply that demand again. And then I think we can enhance their structure and function so that it returns. So I think that there is a lot of that analogy does carry over in that way, because we can see changes in brain structure, increases in brain size in response to cognitive stimulus. But we know that even in older adults, but we know that they didn't grow new cells, right? So either cell volume is expanding, and or we're building additional kind of extracellular structures around those cells, or it's cells that are not neurons that are carrying some of these memories or building or rebuilding some of these functions. So yeah, I think once we've built capacity in the system, that potential is there, even if we don't always use it. But if we then come back to it, we're much more likely to have access to it again.
Josh, who is the author of the book Anyone Can Play Music, was our guest on episode 130. You and Josh recently co-authored an excellent paper titled Demand Coupling Drives Neurodegeneration, a model of age-related cognitive decline and dementia. in this paper, which I think really reframes the topic in some ways. You propose a demand-driven model for age-related cognitive decline and dementia, as it says in the title. You argue that the brain, like other tissues, follows a use-it-or-lose-it principle. Its structure, function, and resilience depend heavily on ongoing cognitive demand, as we have been discussing. And we've talked about today challenging mental stimulation and followed the analogy with muscle. But could you expand a little bit on your paper explicitly? Because I think that paper is an important work.
Thank you. And we also very much appreciated your thoughts, Ken, as we wrote the paper. You know, we sent it to you before we submitted it because we very much valued your input on it, and it certainly strengthened because of that. But this is essentially, this paper was probably the genesis of a lot of the ideas that I wrote about in my book. And I've said several times that, you know, Josh's input was really critical to so much of that. But the idea really was that the loss of function tends to be driven by the removal of inputs that either maintain or build function. And this is something that happens very naturally at the societal level and the individual level as we get older. So, right, we leave formal education and we go into the work environment and we do the same thing again and again and again and again, and we get very busy and we get very stressed, and we stop doing these things that we engaged in when we were first building our cognitive function and we were, you know, primarily professional learners. And as a result, because we stop learning new skills and we stop maintaining the same level of physical activity that we know is so critical for both physical and brain function, then function declines as a result. And we just assume that it's the process of aging that is driving this, but actually it's because we've stopped engaging in the things that the processes and stimuli that maintain function. What this then means, and I think that there's lots of evidence that, you know, we show in the paper that kind of supports this, is that if we instead can, you know, choose to continue to engage in these different activities, we can maintain function even, you know, very late into life. And so when I talk about my idea of headroom, which we've touched upon briefly earlier, I say there's 3 R's of headroom. One is resilience. So this is, you know, how well your brain holds up to the accumulation of pathology with age, which, you know, for some of us is just going to happen regardless. Like, how well do we maintain function in the face of increasing pathology? And so things like exercise are really critical to that. And then reserve. So we talked a lot about reserve today. That's the second R. So reserve is like, how do you build enough volume and function in the system so that if you do lose some function, you can still work well on a day-to-day basis. But my third R of headroom is resolve. It's like, are you continuing to engage in these activities that we know stimulate brain tissue and brain function in order to maintain that function? And, you know, regardless of where you look, we know that the maintenance of any cognitive function in the brain is primarily driven by continuing to engage in the processes that require it. So this then just means that as we get older, we need to actively engage in those processes. And if we do that, I think you could see a completely different idea of what happens to cognitive function with age by sort of stepping away from these larger societal expectations of what happens with aging, that we, you know, become self-fulfilling because of the ways we change our engagement with the world.
So, Tommy, you write in your book about how exercise science and athletic coaching have given us a really good idea of how a specific stimulus affects performance. And so, just as an example, you shoot 50 free throws a day, and you're likely going to get better at making free throws. But when it comes to this kind of measurement and tracking for the brain and cognitive function, it's really hard, isn't it?
Yeah, and this of course, Dawn, this is something you know very well as well, and hopefully that will improve over time. But right now, it's actually very difficult to know how much you're stimulating somebody's brain in any given moment. It's hard to measure the process of stimulation. It's hard to track improvements over time because most of the tests that we have are sort of imperfect in various ways because they have learning effects, or, you know, it's kind of difficult to do them very frequently. Whereas you compare that to, you know, when I was working with athletes, like I can measure their function and performance in a variety of different ways and know how to apply, you know, what we would, you know, if we call progressive overload, if we're thinking about, or you know, a linear progression, if we're thinking about different strategies to improve function by continuing to adapt and apply bigger and bigger stimuli as the body's function improves. It's very hard to track those things in the brain. So some of these ideas, right, we have to kind of look at from a bigger philosophical, theoretical standpoint. I think that when you then look at individual trials that do one specific thing and you look at how the brain responds, you look at how function responds, I think the framework and the ideas hold, but it's still quite hard to do that and really know, like, have you improved somebody's overall brain health and function in a meaningful way that transfers into something that's going to improve their long-term brain health and cognitive function and decrease their dementia risk. Right now, we have to rely a little bit on sort of theoretical frameworks because this stuff is difficult to track. But I'm also very hopeful that that's going to improve over time as technology improves and we have different ways to collect data from people, and we can sort of better iterate and follow these things in real time.
I agree, Tommy. And I think that's going to be critical as we develop out some of these approaches. So really exciting time to think about, being able to have that kind of measurement and, approach for being able to test out different interventions too.
In a lot of ways, it will make all the difference in terms of motivation. I believe so, at least. There are lots of ways that one might stimulate their brain. We've talked about some. Some are clearly better than others, such as learning a new language, or as Josh suggests, learning music. What are some of the other activities that might most effectively increase headroom and cognitive function if practiced diligently?
As we've said several times, I think people understand this idea of use it or lose it, right? That if we want to, and most of us have said that at some point, when you think about retirement or other times when we want to try and maintain cognitive function as we get older. But I think we've kind of, things have gotten a little muddied in terms of thinking about what might work the best. And there isn't one thing that will work the best, but I think we need to engage with activities that are particularly challenging, that drive opportunities for failure and mistakes, right? Because we know that these are important drivers of neuroplasticity. So what that means is that some of the activities that maybe we traditionally think of as being cognitively stimulating maybe aren't quite enough. So, crosswords and Sudoku and Wordle, being the sort of the stereotypical ones. And those can be fine to do, don't get me wrong, but I don't think they're really pushing our capabilities as much as we might want them to. So then, where you mentioned languages, music, there's a whole range of different types of physical activities that we could do that involve multisensory, rapid information processing and strategizing, as well as maybe social connection. So ball sports, board sports, martial arts, and dancing. And several studies show that if you're doing these kinds of activities that have a physical component, but also include additional cognitive stimulus, they have a greater benefit for the brain above and beyond sort of like the physical activity benefit. And so, any of those, pickleball, paddle, badminton, table tennis, tai chi, line dancing, all of these have a very interesting set of evidence to support them. So those are the things that I would focus on, because all of those, languages, music, different sports, they require ongoing rapid information processing and engagement in the environment in a sort of a multisensory way that I think is what really drives brain function. Other things we might include, like certain video games actually have a surprising amount of evidence to support them. Certain brain training programs like Brain HQ has some evidence to support it. And there's one brain training game in Brain HQ that was used in what is to date still the best cognitive training study ever done, called Active, that was done in the 90s. And they had nearly 3,000 people separated into 4 different groups. But one of the groups had a processing speed training that they did for 6 weeks. And then they had refresher sessions at 1 year and 3 years. And those who did the processing speed training, and so the program they did is now in Brain HQ, it's called Double Decision. They had better maintenance of quality of life several years later. They were more likely to stay driving. And there was a paper just published last week showing that those individuals who did the processing speed training and the refresher sessions had a lower risk of dementia, up to 2 decades later. So all of these kind of complex things that are stimulating processes in the brain that we tend to lose as we get older, processing speed, executive function, working memory. I think those are the kinds of activities that we should really engage with. And I've mentioned so many, so that means that you can pick one that you think you'll enjoy and will stick with, and that's going to be the most important variable.
Something else that people could do is think about delaying, putting off retirement or or go ahead and retire and reinvent yourself in some way, engage in some new challenging activity. You write about this in the book, and you note that retirement is the period in someone's life when cognitive function is most at risk. And, that's not surprising. That by definition, it typically occurs later in life and typically involves a reduction in activity and stimulation and challenge. So that's an interesting thought, and I was happy to see it in the book.
There are several studies that look at sort of rates of cognitive decline, either sort of measure dementia risk or model rates of cognitive decline, looking at the effects of retirement. And actually, the greatest risk comes in those who retire early. So it's not just an age effect. And it's after you account for things like medical conditions that might cause you to retire early. But it does seem that retirement is the point when cognitive decline sort of maybe accelerates most rapidly. And yes, there will, of course, be an age component. But because those who retire early are at greatest risk, I think a lot of it is related to the removal of the cognitive and social stimuli that you get through work most reliably, right? That's where we get most of our stimuli on a day-to-day basis. And there are even some studies that show that if you retire and then go back to work, during the period that you're back at work, that risk is mitigated again. So again, kind of suggesting that it really is that the stimulus that's driving a lot of it rather than just age, although age obviously adds a level of additional risk.
Yeah, I would imagine it's both. But in those that retired early, the cognitive decline, as I understand it, wasn't observed during the early period of their retirement. I think what I had read is that they had a greater risk for cognitive decline, measured at the same age point.
Yeah, because they've had a longer period of lower stimulus.
Yes, that's how I took it. Yes.
Yeah, exactly. So this doesn't mean that you need to work forever, right? But like you said, I think it means that people should think about a reinvention or a reinvigoration in skills, hobbies, social activities that can provide similar stimulus that we might get from work. So it's really just knowing that this life transition is going to happen at some point. Can you start to prepare for it by starting to engage in new hobbies, new groups, entirely new skills or fields, so that you then have some kind of ongoing cognitive stimulation once retirement does happen?
We all know older people, and people point at them and say, "My, that's a remarkable person. Look how active and engaged and all the things they're doing in retirement." And I think often the cause and effect are flipped.
Yeah,
they're imagining that the cause is that they're so remarkable. Well, maybe it's all those activities that have permitted them to have such a healthy and engaged aging.
Absolutely.
So, Tommy, another factor that has an impressive effect on brain health is exercise. And we unfortunately live in a society that has become more sedentary. Yet movement is a core requirement of our physiology. So it'd be great if you could talk about your framework that people can use for thinking about movement and physical activity as a way to support brain health.
What's most impressive to me about movement and cognitive function is that essentially the benefits are linear up to a point that's relevant to most people. And what that means is that any movement more than what you're doing right now is likely to translate to improvements and maintenance of long-term cognitive function. And so the framework that I talk about kind of builds on this step by step, depending on where people might start. So if you're starting and you're very sedentary, then the most important thing you can do is just to break up prolonged periods of being sedentary. So we know that being sedentary is associated with an increased risk of cognitive decline and dementia, but the risk is much stronger if those periods of being sedentary are very prolonged. So that means that you could spend several hours a day sitting or whatever, which is actually very normal for humans to do. But you would still, even if you just break it up by moving around, taking the stairs, just not sort of sitting semi-comatose on the couch all day, even that is enough to seemingly have some kind of effect on long-term dementia risk. Then beyond that, just adding in extended periods of low-level movement, right? Walking, cycling, propelling a wheelchair, however you move around the world. We know that up to somewhere around 8,000 to 12,000 steps a day, the more steps a day you take, the lower your risk of dementia. We also know that as you then start to add intensity to that, so maybe your walking becomes brisk walking, you start to see improvements in hippocampal structure and function, particularly in older adults who previously were relatively sedentary. There's a classic paper, again published in PNAS by Erickson et al. That showed that. We know that, so you're breaking up periods of being sedentary, then starting to add some more prolonged periods of movement, maybe starting to add a little intensity so that you feel kind of slightly out of breath. We know that intensity does matter. So one of the best studies that looked at this was published a couple of years ago now, where they took individuals and they had them for 6 months randomized to 3 different groups. So one group was a control group. One group did 40 minutes of jogging 3 times a week, and another group did 40 minutes of high intensity interval training. And this 40 minutes was including a warm up and a warm down. And the interval training group did something that we call the Norwegian 4x4 protocol. So they're on a treadmill. They run for 4 minutes at 85 to 95% of their maximum heart rate. They take a 3-minute break. They do that 4 times over. And they did this 3 times a week for 6 months. And what they saw was that there were improvements in both the 2 exercise groups, but there were much bigger improvements in the interval training group in terms of hippocampal structure and function. And aerobic exercise in general tends to be most beneficial for the gray matter, including the hippocampus, and for memory function. And in this study, they saw that those who did the interval training, they retained benefits from the interval training program 5 years later. So 6 months of a high intensity interval training program, and the benefits were still seen several years later, even though they went back to their previous levels of physical activity. And the primary driver between the 2 training groups wasn't improvements in fitness, because actually they both improved in fitness about the same amount, measured as VO2 max. What seems to happen is that higher levels of intensity, you get greater release of certain exokines or myokines, right? These factors that get released by the body during exercise that then have some effect on they're released by the muscles or the liver or the bone, and they have some effect on the brain. And I think a primary, probably the one that we probably have the best evidence for is lactate. So we know that lactate is an incredibly important signaling molecule. And when lactate is generated during intense exercise, it, as much lactate as you produce gets into the brain. It's the same with ketones, right? They actually use the same transporter to get into the brain, the monocarboxylate transporters. And so the more lactate you produce, the more lactate gets into the brain. And lactate switches on the production of certain trophic factors like brain-derived neurotrophic factor, which we know is important for maintaining the function and structure of recently activated neurons. It helps to support the process of neuroplasticity. So we know that intense exercise can have additional benefits for the brain, and it's probably because of things like lactate. And there are a whole bunch of other things that get released with more intense exercise in an intensity-dependent manner, but lactate is probably the one that we understand the best.
That makes a lot of sense, and it's never too late to get started moving. You write in the book about a study in Norway that found people who increased their fitness in their 50s and 60s decreased their subsequent risk of dementia. Can you briefly summarize this work for our listeners?
Yeah, there are now really dozens, if not more, studies that look at interventions later in life or changes in fitness later in life and show that alters trajectory of cognitive function. So in this particular study, right, it was a population study done in Norway, and they looked at individuals who are like above and below the median or the average cardiovascular fitness and looked at how that changed over time. And so then those who had lower levels of fitness earlier on, but then started to train and improve their fitness, they actually had the lowest risk of cognitive decline and dementia across the entire cohort. So showing that even if you're starting to train in your 50s and 60s, you can see, that seems to be associated with lower dementia risk. And in the study I was just mentioning, using the high intensity interval training, these were individuals in their 60s on average. Other studies show, and sort of when we're thinking about other aspects of brain function, resistance training becomes important. And randomized trials in, again, older adults in their 60s and 70s show that if you begin resistance training, and it's like once or twice a week, 5 or 6 different exercises that cover the whole body, and you can just use machines in the gym, 3 sets of 8 to 12 reps, so like really, really basic structured resistance training, that's associated with improvements in structure in the white matter. So aerobic exercise seems to benefit the gray matter, resistance training seems to benefit the white matter. And that's probably because of the production of things like IGF-1, which we know is really critical for white matter development. Again, very important early in life, in the developing brain, and then also important later in life. So if you do some type of aerobic training, occasionally do some sprints, maybe once a week, you do resistance training once or twice a week, and maybe some of your aerobic type activity includes coordinative exercise or a team sport or a ball sport or dancing, you're really hitting you're hitting the entire brain from multiple different directions, and you're supporting all of those different structures in a slightly different way because of the way that different types of exercise affect the brain.
I'm going to shift topics just a little bit here, Tommy, but all of us, and especially young people, should be cognizant of how social media is contributing to a decline in attention span. And this is really becoming more and more of an issue for people, isn't it?
Yeah. Yes, that is the answer to the question.
Yes.
I think that when we think about these things, probably the most important viewpoint is the one, again, of how we use our brains is the primary determinant of how they function. And so when we're thinking about how we engage in technology, including social media, one thing that we might think about is it taking away from other things that we could be doing to support our health? So people have warned about this idea of digital dementia, such that, as we continue to engage in technologies, different technologies, and we stop doing other things, we have an increased risk of cognitive decline. And everything in that arena suggests that the risk factors for digital dementia are the same as for actual dementia. And what I mean by that is that if you spend so much time engaging, you're sitting and staring at social media, and then as a result, you're not engaging with real people in real life, you're not doing any kind of physical activity, you're not sleeping properly, you're not attending to your diet and these other things that we know are so important, then yes, that's absolutely going to be a significant driver of cognitive decline and changes in cognitive function. And so we don't need to completely reject these technologies, but we do need to be cognizant of how they're affecting our lifestyle more broadly. However, we also know that again, by engaging in these things like social media, especially the way that we use them nowadays, which is we're kind of scrolling on Instagram while we're also on Zoom, while we're also checking our email, while we're also watching Netflix. And it's this kind of multimedia multitasking that seems to have a particularly interesting effect on the brain. And a collection of studies suggests that those who are multimedia multitaskers, right, so you're on your phone while you're also on your TV or your computer, they get better at handling multiple streams of information at the same time. And you can test this in cognitive function tests where you have to do one task, but then you also have to attend to something else at the same time. But interestingly, it also means that people end up being more distractible. So because your brain has moved away from being singularly focused on a single thing at a time, which is what our brains are normally best at, and has sort of been trained to receive and process information from multiple sources at the same time in parallel, that means that we're constantly on the lookout for more information outside of what we're currently doing. So we become more distractible and we're less able to filter out unimportant information. So this all makes perfect sense because your brain is just responding to the inputs that you give it. So yes, we could talk about, right, there are a whole bunch of other things actually that are potentially problematic with social media, particularly as they create social stress that can trigger many of the different physiological processes that we also see when people are socially isolated, related to chronic stress and inflammatory shifts. But I think maybe it's helpful to have a bigger framework, which is that if I'm using my brain in a certain way, my brain will adapt accordingly. And social media and the way it sort of holds our attention, but also the way we use it in a distracted manner with multiple other things at the same time, our brains then respond accordingly. And knowing this, hopefully, then gives us the kind of the knowledge to then apply that in a slightly different way. So, try and do things one at a time. You can retrain your focus, but it requires you to actually engage in a task, and just one task at a time, whilst not having notifications and other things going on sort of around you. But know that how you use your brain is the driver of these responses, and then react and plan accordingly.
Mm-hmm. That's certainly true for driving and texting. It seems that's just everywhere now. It used to be people used to try to discourage it. It seems like culturally we've just given up on that.
Yeah.
Unfortunate. Well, on this note, what about AI? So how is AI affecting our brains today? And what are your thoughts on how AI will affect our brains in the future?
Yeah. this is obviously like a brand new area of research. So it's hard to really say exactly what will happen. But there's already some initial studies that suggest that when we're using AI to perform some kind of cognitive task for us, we see less activation of the networks in the brain associated with that task, as you'd expect, because you're not actually using your brain in the same way. And overall, the quality of the work, at least right now, is lower. But this makes perfect sense, right? You're using your brain in a certain way, and if you're not engaging with a task, you won't then reap the benefits of that engagement. I think we can also think about the fact that as technology advances, how we use our brains is probably going to differ and change. And I don't think we can completely avoid that. So one example is the Google effect. This is a famous paper published in Science by Betsy Sparrow, where they gave participants information, and then they had to store that information on a computer. If the participants thought that the computer had saved that information so they could access it later, they were less likely to remember that information and more likely to remember where that information was stored. That didn't mean that they couldn't remember. They just remembered something different. And in that same study, they showed that if they thought the computer had deleted that information, they then actually remembered the actual information. In a world where there's so much information now that we have to deal with and process, we might see our memories shift from remembering the actual facts to remembering where those facts are so that we can access them in the future. I would argue that's not necessarily a bad thing, because we just have to shift the way our brains are being used. However, when you think about AI, and we know that if you're giving tasks to AI, then your brain will not be engaged in those tasks in the same way, and you will also then not either build or maintain any skills required to perform that task. So the way that I think about it, kind of similar to the social media question, is, are you using this tool to either augment your current capacities? And there are some of the studies on AI show that if you do the task first, and so this was writing essays, if you write the essay first, using whatever you know already, and then you go to something like a large language model and say, how could I improve this? What didn't I think about? What have I missed? How could I do this better? Right. Then you're learning you're learning more, and you're expanding your capacities, you're expanding your capabilities. So some people call this a cognitive orthotic. Did I stole that from you, Ken? I might have stolen that from you.
Yes, but that's the key distinction, I think.
Yeah.
I would take most of these AI and brain papers with a massive grain of salt. But it was the same for calculators. We aren't not diminished by the existence of calculators as long as our pursuit of mathematics doesn't stop with arithmetic. So
exactly.
if you think of it as a cognitive orthotic and it's used that way, very helpful. On the other hand, many people seem to want to use it as a cognitive prosthesis.
Yeah.
In other words, they don't need a brain. If you have a prosthetic leg, it's because you don't have a leg.
Yeah.
I think that's quite unhelpful. But this subject is one that gets tangled up pretty quickly, and I was pleased to see the direction you're taking.
Yeah, so like that, like prosthetic versus orthotic. And so I think about augmentation versus atrophy, because we know that when you don't use a skill, then that skill atrophies. And I see this in real time with some of my colleagues, right? They no longer are capable of writing an email because a chatbot does it for them. And, it's now widespread in academia, unfortunately, where people use AI to design their experiment, analyze their data, and write their paper. And no science was done by that person because they weren't actually engaged in those processes. So I do worry that we will lose skills or never gain those skills because we'll just we'll just become very good at writing prompts for ChatGPT. But there is a version of this, like you said, where we instead use it as a calculator to do bigger and harder things that still require some higher cortical input.
Right, and one hopes that large language models are not the stopping point. These are fundamentally flawed and very close to a dead end intellectually at this point. So I think there's new approaches there will need to be new approaches in the future. And when people do studies on AI and social science or AI and brain health, it's always using some kind of a pretty simplistic chatbot kind of thing. And one can imagine much more effective cognitive orthotics.
Yeah.
Tommy, The Stimulated Mind is an excellent book. It's coming out March 24th and is now available for pre-order. Writing a book is hard work. I'm still scarred from it. A number of our guests have said that after writing their book, they don't want to ever do it again. However, I understand that you're already thinking about your second book. Pray tell, what will this one be about?
Great question. I have promised my wife, Elizabeth, that I will take a break from book writing and book promotion for at least a little while, and certainly need to get back into the lab and work on lots of exciting projects that we've got going on. But I will say that, sitting down and reading research and thinking about ideas is just one of the biggest absolute pleasures that you can have as an academic, I think. So I really enjoyed that process for the book. And I think that probably one area that, or there are two potential avenues that could be explored further in the future. One, I've had lots of people ask about the developing brain and kids, particularly as the modern environment changes, and so that's an area that I've thought about a lot. And then also how our brains might change in the modern technological environment, things like AI and that kind of stuff, and how interacting with them might affect the brain. But one reason why I would potentially wait to write something like that is, as you said, we're right at the beginning of some of those studies, and we don't really understand a lot of what that is or what it could be. And equally, AI is going to change so rapidly that something you write is going to immediately be out of date.
Yeah.
But equally, I think if you come at it with this idea of frameworks of engagement and stimulus, potentially there's something useful there. So those are two ideas that I've sort of noodled on, but maybe it's a couple of years before they mature enough to be able to tackle them.
Yeah, well, that would be incredibly exciting. We will be keeping our eyes open for the next book. So you mentioned your wife, Elizabeth. Before we go, I want to ask you how she's doing. So she is Tommy's wife, as mentioned, and also is our guest on episode 71. And she's also a researcher at the University of Washington. So what's she up to and how's she doing?
She's doing great. She in September, she became department chair of chemical engineering at the University of Washington, and is really enjoying that. I mean, she's just as well as being an exceptional scientist, she's an exceptionally good leader and administrator of people and sort of big groups, and trying to navigate changes in the funding environment and all these other things that are putting universities under a lot of pressure. So yeah, she's doing very well and being asked to do increasingly important things by government agencies and presidents and provosts of universities, and just generally being a bit of a rock star. So it's very cool to get to see that, and interesting to juggle sort of things going on with my book and her sort of trajectory upwards in academic circles. But certainly a super interesting time, and really fantastic to be able to see her do that.
Well, I'm a big fan of hers, both her research and her leadership style, and following all of her updates. So I can imagine how busy you guys are with all the things that are going on. You guys are a rock star couple, that's for sure. And she's from North Carolina, like me, and like you, Tommy, she appreciates a good barbecue. And after you guys moved to Washington, you mentioned in one of your interviews that you guys weren't having much luck finding good barbecue in Seattle. Has your luck changed? Asking as a North Carolinian, by the way.
Yeah, so when it comes to North Carolina barbecue, unfortunately not. But I will say that there are a couple of good Texas-style barbecue places that have popped up in Seattle since we last spoke about that. So yes, the barbecue world has improved up here, but anybody who wants to do more North Carolina-style barbecue, please come up here and we will eat lots of it.
Texas brisket is my favorite.
Yeah, me too.
Well, Tommy, thanks again for joining us today. It's always fantastic to speak with you, and good luck with the book tour. And please give Elizabeth our best.
I will do. Thank you so much.
Yes, Tommy, thank you very much.
STEM Talk. STEM Talk. STEM Talk.
STEM Talk. STEM Talk.
So, Ken, I always enjoy talking with Tommy, and I really like Tommy's analogy that the way our brains adapt to an appropriate stimulus is very similar to how our muscles respond to exercise. It kind of reminds me of that saying, use it or lose it, and that really applies here to the brain, too.
Absolutely. As you know, Don, you've heard me talk about the zombie apocalypse. Just walk down the street or through an airport terminal and watch how many people seem to be hardly alive, apart from their apparently deep connection to their phone. Unfortunately, as people age, and especially after they retire, they often stop challenging themselves and their brains, and they fall into what I like to refer to as a zombie-like rut. Of course, one sees many younger zombies as well, but their zombie affliction apparently has some other causes, as well as disuse of their brains. Tommy's book offers an excellent framework for avoiding this rut. He provides science-backed strategies for stimulating and nourishing our brains as a way to protect ourselves from dementia, or at least delay its onset, and hopefully we can avoid the zombie apocalypse.
I truly hope so, Ken. So this is Dawn Carnegie signing off for now.
And this is Ken Ford saying goodbye until we meet again on STEM Talk.
Thank you for listening to STEM Talk. We want this podcast to be discovered by others, so please take a minute to go to iTunes to rate the podcast and perhaps even write a review. More information about this and other episodes can be found at our website, stemtalk.us. There, you can also find more information about the guests we interview.